Okay, so we have 5.2 slope fields. We only know how right now to solve separable differential equations. In Calc 2, you learn a numerical way to solve, and so we're also going to have a graphical way to solve, and this is by slope fields. All right, so for example here, this kind of is what a slope field looks like. It's a bunch of little dashes, and you just kind of follow it. And so it's our job to figure out what these dashes are. And when you draw graphs, you kind of just follow the arrows, to see where it goes. So maybe your graph's going to start here, and it's going to flow something like this. And so we'll see this slope field. It turns out looking pretty cool. It can be a bit repetitive and redundant, but we're going to take a look. All right, so you can read through all that. In general, the slope field is usually you get the differential equation, and your job is just to plug in values and figure out what the slopes are. So our first example we're going to do is x squared. That's the differential equation, and we're going to try to draw the solution to what the y equals equation would be. All right, so in order to do that, we have to think about this, and it's easier if we can do this in patterns. So when x is 0, the slope is 0. So we're just going to draw little markings to represent a 0 slope. When x is 1, the slope is 1. So we're really going to try to get this. They shouldn't curve, but it's the way my pen's working. They really should be consistent. All right. So it should look something like this. When x is negative 1, the slope's also 1. Okay, so you really want to hit the zeros, the 1 slope, and infinite slopes. Otherwise, you just kind of, it's all relative. Now, if you plug in 2, this is a slope of 4, so it should get very steep here. And if you plug in negative 2, it's also very steep. Oops. Okay, so this is a slope field. That's it. That's all there is to drawing this. And then what this is useful for is you can visualize what the solution curves may be. And if you think about it, if you take the antiderivative of x squared, you get 1/3 x cubed. And if you follow along this path, you kind of get that x cubed pattern. Okay, and whether it's up or down, maybe it's up here, maybe it's down here, but it's something like that. And so that's our idea behind these. We're using these to graphically view a solution. All right, so as I noted, you want to be really sure of your slopes of 0, 1, negative 1, and any infinite slopes. Everything else is just relative. And if you're drawing a particular solution, you got to pass through whatever point they give you, and then it needs to be continuous and be a function. So if we made even more points for our last graph, it could look something like this. Okay, and you can use your calculator, you can use computer systems, different softwares to build these slope fields for you because they can be a bit repetitive. All right, sketch the graph of the solution for the non-separable initial value problems. If we had this function, we couldn't solve this using our methods that we've tried before because we can't separate the variables. So we have to just try to visualize it here. And so you want to just try to do what you can. So we know, like, when x is 0 and y is 0, the slope is 0. If x is 0 or x is negative 1 and y is 1, it's 0. Same thing over here. So you kind of can build patterns. That's helpful. And then you just kind of have to go around that. So, for example, this point, that is 1, 0. So that slope is going to be 1. Okay, this point is 2, 0. So this slope is going to be a little steeper than that. Okay, up here, this slope is going to be 1. This slope is going to be 1. These should all kind of look the same. All right, and then we have 1, 1, so that slope is 2. So that should maybe look something like that. This one's going to be a little bit steeper. Over here we have x is -1, y is 0, so we have a -1 slope. Okay, if we go to this one, -2 and 1 make -1. Okay, this would be -1. And get a little bit steeper, and even more steep. All right, so we have all of our, we have the slopes. Now we're going to sketch the graph for each of these. So we're going to go through the point 0, 1, and we're just going to kind of use these to guide us along. So it looks like we kind of have a slope like that, and it looks like it's getting a little steeper. As we come over here, it gets a little flat, and then it kind of goes back up. And this, you get better with practice. All right, let's look at the next one. So if we start maybe here, I guess right there is good. It kind of curves down, right? We're kind of like doing something like that, I guess. Looks like, you know, imagine you're a leaf and you're blowing in the winds of this slope field. And then we'll do this one, -1, 0. Well, that's a slope of -1. This is a slope of -1. This is a slope of -1. It looks kind of linear. All right, so we're not trying to find equations. We're just trying to visually see what's going on. All right, so we'll do a couple more of these, but I don't want to overkill this too much because it could be a bit repetitive, and I think that you guys can get it. All right, so but let's try. We're going to sketch the slope field, then sketch the solution curve that passes through the origin. All right, so I'm going to pick out when x is 0 and y is 0, the slope is -1. All right, that was easy. X is 1, y is 0, -1. All of these end up being 0. That's nice. And then 1 + 1 - 1. Oh, that should connect. I don't know why it's not. All right, good. There we go. All right, so now we're going to draw our solution curve that passes through the origin. Looks like we should go down this way and kind of curve back up. Okay, we're going to go up this way, and now the wind's blowing this. All right, so maybe it would look something like this. And in fact, this is a little bit bigger slope field of that, and you can kind of see that curve building in there. Nice continuous functional curves. And now depending on our starting point, maybe we would start here. You know, it has to go through this point, or maybe it would go through, you know, a point over here. It depends on what point you start at on what your particular solution would look like. All right, so do we do this one? No, I think you can do it. So we're going to skip this one for now. Let me just make a note of that. All right, so now we get something a little bit different. We see the graphs, and we have to match the equation of the general solution it could represent. So if we just pick somewhere to start, maybe here, we kind of graph it, we follow along the lines. What does that look like? Looks like sine of x to me. Okay, so that solution, that general solution could be x, sine of x. This one maybe kind of looks like this, and now it kind of goes like this. So that's definitely not y = 1, y = x. X squared, no, that would be more parabola. X cubed over 6, sure. It kind of looks like it could be that. All right, let's look at example 6. The slope field for a certain differential equation is shown above, which could be a specific solution to that. So our graph, whether it moves up and down, it's kind of like this. So really only one of these looks like that. It would have to be ln of x. All right, so we'll do example 7, and then I'm going to have you do example 8, and we'll talk about that in class. So match the slope field with their differential equations. All right, so some of these are glaring at me at places to start. Do you see that little line there? Y = 2, the slope is 0. So I want something that's going to give me that, and so I kind of see this there. So let me just test a couple points. Any y value above that line is negative, because 2 - 3 is negative, 2 - 4. And then anything below that is positive, like 2 minus 0, 2 minus negative 1. So that looks like that would match this one here. All right, let's pick out another one. So I kind of want to work with, oh, I don't know, this equation right here. I know that the antiderivative of that is something like x squared. So that's what I'm looking for. So I'm trying to see, and it looks like this one kind of has an x squared shape. So that must be letter A. I guess I should write letters. This one's B. All right, let's go with letter. Let's find a different one now. Um, so the antiderivative of e to the x is e to the x. So that kind of, well, that didn't trace very well, but neither did that. I'm not following the wind here. It gets really steep, so I'm guessing that one's this. That's F. Let's see if we can't figure all of these out. Sine of x, I'm looking for something that's oscillating. I'm guessing that's D. See, look how it goes. Kind of missed that, but there we go. That looks something like this. So I know it should be some kind of sinusoidal one. So now I have two left. And one thing to keep in mind, I have a fraction here. So that's going to be a problem. Whenever y equals 0, we can't divide by 0. So it's kind of hard to see what's happening at 0, but maybe I'll just pick something else. If we look in the first quadrant, all of the slopes are positive. So when x is positive and y is positive, the slopes are positive. Okay, when x is negative and y is positive, the slopes are negative. This looks like it's falling out nicely. So we have negative and negative, positive and negative there. Looks good. So I'm going to go with that one is C. And so that follows along that this must be E. And whenever the x and y values are the same, the slope is 0. So that matches well. All right, so you see how I did that there? I would like you to do example 8, and we'll talk about this in class. If I could write class, there we go. Sure. We're going to talk about example 8 in class.